Hello, this is Mr. Stansbury. I'm going to take you through the notes for graphing systems of inequalities. At the end of this, you should be able to say, I can represent constraints by equations or inequalities, and I can use a graph to determine solutions of a system of inequalities. Okay, so let's just do this. Let's just get straight into an example, which will help us understand this much quicker. All right, so Chadley is planning a trip to Australia to go see his all-time favorite event, the Australia Day cockroach races. Chadley has budgeted $700 for the races. Each of the 4 race sessions cost $150 to attend, and then each individual cockroach that is racing has a commemorative pin that costs $27 each. Okay? Chadley wants to go to all 4 sessions and buy a pin for each of his 12 favorite cockroaches. Does he have enough money budgeted? So let's see, 4 sessions times $150 plus 12 pins, which all cost $27. Let's see what that gives us here. So if we do that, 4 times 150, and then we're going to add 12 times 27. We get $924. 924. So no, he does not have enough money budgeted. Okay. What combinations of race sessions and pins can Chadley afford given his budget? Interesting question. So he could do, let's see, all 4 races. Right, 4 races, which is 4 times 150 is $600, and then that would leave. It's got $700, so then that would leave $100 left for the pins, right? So if he bought 4 pins, that would be over $100, but if he bought 3 pins, that would be 3 times 27. That would definitely be under $100. So he could do 4 races and 3 pins, right? So let's see, 3 times that is 1. 3 times 27. Sorry, it's 21. 3, 6, 7, 8. So that's going to be $681 for that. Okay. He could also do 3 races, which would be $450. And then he can add how many? Let's see. That means he's got. Let's see if we take 700. Just trying to figure out. Okay, let's just do this. 700 minus 450 is going to leave him with $250, right? So if we take 250, divide it by 27, that'll tell us exactly how many pins he can get. 250 divided by 27. That gives him 9.25 pins. Can't buy 2.5 pins, so we would have to go plus 3 races and 9 pins, right? Okay, and then could also do potentially 2 races, which is what, $300, and that leaves him $400 for the rest. So that's 9.26. Get rid of the 0.26, so that's where we get the 9 pins from. So then now we could take, I didn't leave much room to do work, did I? So if we take $300 just for the racing, so we take 700 minus 300, leaves us with 400. So we can take 400 and divide it by 27 to see how many pins he could get that way as well. 400 divided by 27, 14.81 pins. So you could do plus 14 pins. Okay, because this was, what did we say, 14.81? 14.81. Get rid of the 0.81. So these are the 3 best combinations. 4 races and 3 pins, or 3 races and 9 pins, or 2 races and 14 pins. Could also do 1 race and a whole bunch more pins, or no races and even more pins than that. But these are probably our 3 best bets here, right? Okay. Write a linear inequality that represents all ordered pairs that worked for Chadley's budget. Okay. Let's take a look at that. Okay, so we know that he has budgeted $700, so he can't spend any more than that, right? So $700 has to be greater than or equal to how much he's spending, right? And he spends $150 for every race session attended, so I'm going to do 150R. And then also spends $27 on every pin, so I'm going to do plus 27P. Okay, and then so you could even put a little like legend over here of like R equals number of races. Let's see, it's the race sessions attended, and then P is number of pins bought. Okay, it's always kind of nice to know what your variables are standing for there. Okay, so we know that 150 times the number of race sessions that he attends plus 27 times the number of pins that he bought has got to be less than or equal to $700. Okay, so there's our linear inequality. All right. Using our inequality, how many pins can Chadley buy if he attends 2 sessions? Well, we already actually figured that out over here, but let's use this to try to show that we can actually use this equation here as well instead of trying to go through and figuring it all out that way. So we got 700. It's got to be greater than or equal to 150 times 2, because it says he's attending 2 race sessions, plus 27P, right? So this is 700 greater than or equal to 300 plus 27P. Subtract the 300 from both sides. Right, and we get 400 is got to be greater than or equal to 27P. Right? Okay, so we divide both sides by 27. And we get that P. Oops. Let's even do this. Let's leave P on the other side so it doesn't mess up our inequality here. P has got to be less than or equal to, so that goes away, 400 divided by 27. So, look, we already did that, 14.81. So, P has got to be less than or equal to, we could do 14.81, but that wouldn't make sense because you can only buy whole numbers of pins. So, 14 or less, which is what we came up with here. Okay, and then last step, graph your inequality from part C and graph your points from part B. But before we do that, let's take a quick little comedy break.
When you get on an escalator, do me a favor, just grab the handrail and just stand there. Let life take over, let it raise you from one floor to another. Can't stand the people who still feel the need to walk. Same idiots always. It's usually the guy with the NutriBullet full of greens. That guy, excuse me! On the left, excuse me. I don't let him by. I get all big. I'm like, nope, not happening, no. No. Excuse me, nope, not happening. Big man Pilates time.
All right. So last one, graph your inequality from part C and graph your points from part B. So let's do this. Let's put a little graph up there for us. And then away we go. So graph your inequality from part C and your points from part B. So let's do this. Let's do our points from B. So this is the, gosh, we can do either one of these on one. Let's call this P. So this is going to be number of pins bought. Okay, so we can go up to what, like 14 or maybe even more. So let's make this max out at say 20. This is 10, so these are going to go up by 2. Okay, and then this is going to be R, the number of races. Now you can only do 4 races, right? So let's do this. We don't want to have everything in the bottom little teeny piece of our graph. So let's do this. Let's do 1, 2, 3, 4. We want to try to use at least 50% of our graph when we when we do that. Okay, I'm trying to get rid of that. Sorry, that's not working. I'm going to get rid of it. Aha, I beat it. Anyway, so let's do this. Let's go through, and then let's graph the points that we already had here. So 4 races, 3 pins. So this is our races. Okay. And so let's see, 4 races only gives us 3 pins. So that's going to be right here. Oops. Go 4 races, 3 pins. And then we also have 3 races and 9 pins. So 3 races goes over to 9 pins. So that's right there. These are points that actually work. 2 races gives us 14 pins. Okay. Now, this one here, we're not going to necessarily connect these dots here because these are actual like whole numbers that work. We're going to actually want to, where we're going to want to draw our line is on our linear inequality piece here, right? So that's where this piece here is going to come in. Okay, so really what we need to do here is we need to come up with basically our easiest way is probably going to be find our x-intercept and our y-intercept. Okay, so let's do this. Let's just say we put p equal to 0. So we'd have 700 greater than or equal to 150r plus 27 times 0. So we didn't buy any pins. So we'd spend everything on races. So we divide both sides by 150. R equals, let's see, 700 divided by 150 gives us 0.466. I'm going to put that into a fraction, which on the graphing calculator is math, enter, 7/15. Oh, I only did 770. That's probably part of the problem. 700 divided by 150. That's better. 4 and 2/3. Okay, so here's 4. Here's 5. 4 and 2/3 is going to be about right here. So let's maybe do this inequality here. We're going to do this here in orange. So 4 and 2/3 is about right there. And then we can do the same thing. So let's see. Sorry, I got to finish my ideas here. 4.667. Right? And then we can do the same thing over here where we put in 0 for r. So we're going to do 700 when that is greater than or equal to 150 times 0 plus 27p. So that turns into nothing. And we would divide both sides by 27, and that will tell us what our y-intercept is over here, which looks like I didn't leave us enough room, but that's okay. We'll make it work. So now we do 700 divided by 27, 25.9. So P equals 25.9. Okay, so again, that is an oversight on my part there. 22, 24, 26. So 25. So just about right about here. Oops, let's do that also in orange. So right about there is going to be our other y-intercept, and then we just connect these 2 dots. Okay, and our inequality is greater than or equal to, so that means that we can leave that in as a solid line. So anything underneath this line here is going to work, right? Like if we didn't go to any races, the easiest way to check is to do 0, 0. If you went to no races and bought no pins, that would leave you under your budget. So it's going to be basically anything in this area here. And if you'll notice, these dots here are all underneath this line. So that's another way that you can tell. Okay. Okay, that's all we have for this section here. If you have any further questions, please feel free to ask. Thanks.